morning students, this is Dr. V. Srinivas Rao, Assistant Professor of Physics, GDC Uppal. So, today we will discuss about the low temperature physics. So, in this here what are the methods which you have been achieved. So, in this Joule Kelvin effect, adiabatic demagnetization. So many different methods are there. So, to achieve the low temperature. So, before that we will discuss about the here phase diagram. So, what is the low temperature? So, which is known to the physicist was that here ice temperature. So, that is 0 degree centigrade. Okay. So, here the steam temperature is 100 degrees centigrade. So, which is very near to the triple point of water. So, at this temperature sublimation curve, fusion curve and vaporization curve meet. So, from the figure we can able to see that here temperature versus pressure curve. So, in this melting and freezing. So, that should be takes place between the solid to the liquid, whereas here liquid to the gas. Okay. So, there should be here vaporization as well as the condensation process is going to be takes place. And what is the sublimation and deposition should takes place in between solid to the gaseous state. Okay. So, and also here from the figure we can able to see that here what is a critical point. So, here in this in detail we should discuss about the here what is liquid vapor curve. So, from the liquid vapor curve, vapor pressure of saturated vapor depends upon temperature alone only. Okay. So, which could depends only on temperature. So, this should increase with the increase of temperature as a curve of vaporization. Okay. So, next one is the fusion curve. So, the solid may exist in equilibrium with the liquid state, and the pressure temperature curve in this case you can known as here fusion curve. And third one is that sublimation curve. So, the solid may coexist with vapor in the equilibrium state. The temperature and pressure curve at which the solid and vapor may exist in equilibrium, which is known as sublimation curve. So, you need to know about the what is the triple point. So, just now we discussed about that here what is the triple point curve. So, in this which is a point at which the temperature and pressure are such that the solid, liquid and vapor phase coexist in equilibrium. Okay, that is in stable state. So, next one most important here is the experiment is that porous plug experiment. Okay. So, there are two main essay questions are there. One is that Joule Kelvin effect and another one is that adiabatic demagnetization. So, you may expect these two questions in examination point of view. Let us discuss about that by using the Joule Kelvin effect or Joule Thomson effect here. Yesterday's class we have been discussed that Joule Kelvin coefficient. Okay. So, today we are going to discuss about that in the low temperature physics, how the gases which are going to be getting at lower temperature. Okay. So, here first is that porous plug experiment. So, from the figure we can able to see that there is a box wooden tube. Okay. So, this is a insulated material and towards the left and right you can see here the mouse. So, the left is one piston is there and right is also another piston is there. So, from the left piston to the right piston middle there is a porous plug. So, which is a brass disc which is enclosed here. So, in that a cotton wool is going to be placed. So, this may act like a porous plug. So, through the porous plug whatever the gas which is going to be inserting to the here left hand side, that should be goes from the left to the right hand side from the through the porous plug. So, that how the temperature of the gas which is going to be falling. So, that is to be explained by this experiment here. So, what is the left hand side here you can see here the piston. through the left hand side piston, so the gas is going to be injecting. So initially here the pressure of the gas is Pi and the volume which is going to be occupied by this region, left hand side region, which is the volume is Vi and the temperature of the gas is Ti. So here when the low pressure to the high pressure, the gas which is going to be passing through the here porous plug, the temperature of the gas is going to be falls down. So this is the Joule-Thomson experiment. So this process you can call it as a throttling process. Okay. So that's what here the gas which is going to be entered into this region here, the pressure is initial pressure is Pi, volume is Vi and temperature is Ti. So whenever the piston which is going to be acts upon the gas to escape the gas through the porous plug left hand side region into the right hand side region. So the piston which is going to be acting some work, doing some work on the gas, so that the gas which is easily escapes from the left hand side region into the right hand side region through the porous plug. So that here when the piston left hand side, you can see here the left hand side region we are going to be applying, so that the piston, if it is going to be slowly moves, so the gas is going to be escaping through the porous plug from left to the right hand side. So that what is the pressure is there? So right hand side the pressure is Pf and the volume which is going to be occupied by the gas is Vf and the temperature of the gas is Tf. So in this case right hand side the gas is going to be acting some work on the piston here. Left hand side is piston is going to be working on the gas, and whereas the right hand side the gas is going to be working on the piston. So that the piston which is going to be moves right hand side. Okay. So this is the process which you can able to get the here the temperature of the gas is going to be falls down. So here also here you can able to see this the diagram which is going to be showing here. So one is that topmost is the gas is going to be here entering and the piston which is going to be moves here, the gas which is escaping the left hand side region, and this is the porous plug here through the porous plug here which is going to be escaped. But before that escaping the gas through the porous plug left hand side region, what is the temperature is there, what is the pressure is there, how much of the volume which is going to be occupied, you can able to here measure that. And finally if it is going to be escaping and which can be cooled down here, so a water jacket is going to be takes place, that is water bath is there. So similarly which is going to be comes towards the other side, so that here the gas, here the arrow mark which is going to be indicating here the gas is going to be injecting, and here the gas is going to be here outing here, so that the gas which is going to be works on the piston here. So the piston which is going to be moves here, when here the volume is going to be increases, the temperature of the here gas is going to be decreases. So like that here you can able to achieve this. So in detail we will discuss. So this is from the figure here. So in detail, so what is Joule Kelvin effect? So when a gas under a constant pressure which is passed through a porous plug, so to a region of low constant pressure, the gas suffers a change in temperature. So this was actually demonstrated by Joule and Thomson, and hence which is known as Joule-Thomson or Joule Kelvin effect. So what are the results they have been observed here? So first point is that all gases suffers a change in temperature after passing through the porous plug. Okay, all gases, and whereas at ordinary temperature all gases except hydrogen and helium shows cooling effect. Okay. So here at 0 degree centigrade hydrogen shows a heating of 0.04 degrees per ATP, atmospheric pressure difference. And third one is that the change in temperature Tf minus Ti which is directly proportional to the difference in pressure Pf minus Pi. So, change in temperature increases, change in pressure is also going to be increases. Change in temperature decreases dt and dP is also going to be decreases. You need to note it down here. So, that is what here the third point is that here the change in temperature is directly proportional to the difference in pressure on these two sides of the porous plug. Okay. Next, fourth one, the fall in temperature for atmospheric difference of pressure decreases as initial temperature of gas is raised. So, above this temperature, instead of cooling, heating is observed. Okay, the gas is not going to be cooled down here, the gas which is going to be heated up. So, the temperature at which Joule Kelvin effect changes the sign is called temperature of inversion or inversion temperature. So, thus every gas below its temperature of inversion will cool on passing through porous plug. So, the inversion temperature of hydrogen is minus 80 degrees centigrade. So, by doing the derivation from the van der Waals equation, so here what is the work done on the here gas here, and initially what is the pressure difference is there, initially what is the temperature difference is there. So, by choosing the work formula PdV, W equals to dW equals to PdV, and here you can able to achieve the equation here. So, that final equation I am going to be showing here, you need to do the practice here. So, the change in the temperature. So, how do you derivated these final equation means here by using the van der Waals equations. So, that is the final temperature dt equals to P1 minus P2 by Cpj, okay, where Cp is the here specific heat at constant pressure, okay, into 2A by RT minus B. So, this is the final equation. So, in this equation, if 2A by RT which is greater than B, then dt value change in temperature is positive. If it is positive, there will be a cooling effect because dt represents the fall in temperature. Okay. Next one, if 2A by RT which is less than the B value, then change in temperature is negative. If it is negative, there will be a heating effect is going to be takes place. Okay. If 2A by RT equals to B, that means by substituting you will get the dt value is 0. So, that there will be no effect, that means the gas neither cold or heating effect should takes place. Okay. So, the temperature at which Joule-Thomson effect is 0 and changes the sign is known as temperature of inversion. So, that is going to be denoting here Ti. Therefore, you know pretty well 2A by RT if it is equals to B or Ti equals to 2A by RP. So, that here the inversion temperature formula which can gives you 2A by RB. Next, another one is that here most important, this is also an expected essay question, examination point of view, liquefaction of helium gas by using Kapitza's method. So, in this what is the important modification? So, here which was made by Kapitza in expansion engine. Okay. So, here there is no lubricants which is used here. Okay. So, what is the lubricant use of this lubricant here? So, to here reduce the friction here between the piston to the chamber. So, but here there is no lubricant used. So, if you are going to be using the lubricants here at lower temperature, the lubricant becomes solidify, okay, solidify at lower temperature. So, used the compressor where the piston is loosely fitted with the cylinder with a very small clearance. When expansion is takes place, a little gas escapes through the clearance. Okay. So, pure and dry helium is compressed by 30 ATP by compressor P. So, we are going to be here applying that some here pressure here, so that the gas which can easily escapes. So here which gas he is using here? Helium gas. Why? Because of the method is that Kapitjas method, liquefaction of helium. So here the heat of compression which is removed by flowing of water, when you are going to be applying such a pressure on that, automatically the temperature of the gas which is going to be increases here. So that how the temperature of the gas which is going to be reduced means here a flowing of water in a jacket surrounded by a portion of the tube. So the gas is then pre-cooled by passing through it bath of liquid nitrogen boiling under reduced pressure. So here from the figure you can easily see that here the piston is there. Okay. So here by using the piston, the helium gas which is going to be inserting here. So helium gas is there. So which is going to be escaping. How the gas is going to be escapes here? When the piston is going to be doing some work on the gas, so that the gas easily escapes. So through this, so here surrounded some water jacket is going to be surrounded by this. So that what is the water jacket here? The water which is going to be flowing in and the water which is going to be flowing out. That means the temperature of the gas which is going to be decreases. Why? Because of the piston has done some work on the here gas. Okay. So to reduce the temperature initially, again the gas which is going to be enter into the liquid nitrogen bath. So the liquid nitrogen bath temperature is minus 208 degrees centigrade. So that here the temperature of the helium gas which is going to be falls down, and which is going to be enter into the heat exchanger chamber here. So easily the temperature of the here helium gas which is going to be reduces, and which comes towards the nozzle here. But before that, if it is not going to be cools down here, there is a expansion engine is there. So which is going to be entering here, where the pressure is going to be reduces, automatically the temperature of the helium gas, that means here minus 208 degrees centigrade is there. So here there is a exchange between the minus 208 to minus 263 degrees centigrade. That means here there should be a regenerative process is going to be takes place between these two. So that whenever the gas which is going to be here cool down, which is going to be gets here in the liquid form, that means here minus 268.8 degrees centigrade. Okay. When the gas is not going to be cools down here, again which is going to be goes into the initial position, and these are the arrow marks which is going to be showing here, and which these are going to be entering into the same piston here. Okay. This is the chamber. Again the process till the gas will get cooled down, the process is going to be here repeatedly takes place. So that what is the here temperature of the helium gas which is going to be achieved here, that is minus 268.8 degrees centigrade by using the Kapitjas method. Okay. Let us see that here the pre-cooled gas which is divided where in expansion engine here. So at A in the heat exchanger, one part passes through the expansion engine, and due to the adiabatic expansion, okay, here adiabatic means there is no here the gas cannot be the temperature cannot be moves from the inside to the outside or outside to the inside here. So adiabatic expansion is going to be takes place, expansion not compression. So that the gas is going to be cools down minus 263 degrees centigrade. So this rise up the heat exchanger and cools the second part which is coming towards the nozzle N. So it is liquefied, the gaseous state which is going to be liquefied. So the liquefied portion is collected in Dewar flask, and the remaining part which goes back into the compressor through heat exchanger. Okay. Next, last one is that adiabatic demagnetization. So here the lower temperature were explored by Debye and Geck in 1926 independently by adiabatic demagnetization of the paramagnetic salts. Okay. So, see here what is the principle which is going to be involved in this adiabatic demagnetization. So, when a paramagnetic substance, so which substance it is? A paramagnetic substance, okay, dia, para, ferro. So, in this we are using here a paramagnetic substance which is already magnetized, so it is suddenly demagnetized. So, it shows that a slight fall in temperature. So, if the substance is already at a sufficient low temperature, the fall in temperature is considerable. So, here the figure which is going to be indicating here which is this, you can able to see that a paramagnetic salt is there. Gadolinium sulfate is going to be choosing here in this experiment. So, here a solenoid coils are there. Okay. So, D1 is one Dewar flask, D2 is the another Dewar flask, okay, and surrounded by this a strong electromagnetic poles, a north and south pole. So, to evacuate pump here, so something which is going to be takes place. So, here you need to know that here what is a adiabatic demagnetization. From the figure you can able to observe that here a paramagnetic substance. What is that paramagnetic substance? A gadolinium sulfate, which is suspended in a vessel capital A, so which is connected to a vacuum pump. So, that here the vessel A is surrounded by a liquid helium. So, what is the temperature of the liquid helium? Minus 268.8 degrees centigrade. So, that at this temperature 1 Kelvin which is placed in Dewar flask capital B, okay, there only you can able to collect this liquefied gas. So, this is again surrounded by another Dewar flask capital C which is containing a liquid hydrogen. Okay. So, a strong magnetic field which is going to be applied to this magnetized the paramagnetic salt. So, the coil capital M, round capital A are used to measure the temperature by which method? A susceptibility measurements. So, first of all capital A is the filled with the helium gas, so that the substance gadolinium sulfate capital P becomes in thermal contact, okay. So, of the liquid helium with, so that here again which is going to be cooled down to the 1 Kelvin. So, a thermal contact is, that means here there should be a heat exchanging is going to be takes place. Why? Because of there is a liquid helium is there, that is going to be here whenever the strong magnetic field is going to be applied here, inside that magnetic field domains are there which are going to be here colliding with the walls of the here paramagnetic salt and also colliding with each other, there the temperature is going to be rises here. So, that in that case the temperature is going to be increased. So, for that case here the temperature which is going to be exchanged here automatically, which is going to be cools down to 1 Kelvin. Next, the magnetic field which is going to be switched on, so that the alignment of these domains which are here turn up into this particular magnetic field. So, the P becomes warmed up and the heat flows through the helium gas into the liquid helium, just now we discussed here. So, the temperature P falls again, which is going to be decreases to 1 Kelvin. After this helium gas is now pumped out from the vessel capital A. So, the substance becomes thermally insulated, okay, not in contact, thermally insulated. So, that the magnetic field is going to be switched off. So, due to this adiabatic demagnetization of this substance, its temperature falls down. So, the fall in temperature detected by the susceptibility measurements of the coils. So, by this above procedure, so many scientists have been achieved different lower temperature of the different materials. So, that one is that here organic and McDowell reached the temperature of 0.25 Kelvin. In 1944, Whitehouse using double sulfate of potassium and aluminum, which is obtained a temperature of 0.002 Kelvin. Next is Clark, Steenland and Gorter using crystals of chromium, aluminum, alum reached to 0.0014 Kelvin. So, this is the temperature of the lowest temperature reached so far. So, here again, so some of the mathematical expressions which is going to be involving in this to derive the temperature equations. There is a how the fall in temperature, initially what is the temperature of the substance and finally what is the temperature. So, what is the difference in the temperature of this substance, a paramagnetic substance. So, that here you need to do the previous class we have been discussing the Maxwell's equations, one of the Maxwell's equations which is going to be using here to derive this equation. So, that let Ti and Tf be the initial and final temperature of the specimen correspond to the initial and final magnetic flux densities Ba and Bf respectively. Then Ta and Tf, Ti minus Tf which can gives the K by 2 Cbt into Bf square minus Bi square, where K is the C by M which is called Curie's constant per unit mass. Okay. So, these are the methods. One is that here Joule Kelvin and another one is that liquefaction of helium, Kapitja's method. Third one is that adiabatic demagnetization. Okay. So, by coming class we will discuss in applications of lower temperature. Thank you.